Two of the following videos are true, while the other one is trash. Can you spot the fake? Season 4, Episode 6. Round 1, let's begin. If you place 3 dice on a table, you can use a cup to quickly scoop up the dice in a continuous motion. Then bring them to a stop carefully, and all 3 dice are stacked on top of each other. With the right technique, you can do this somewhat consistently. First, fill up a plastic container with water. Then fill up an insulated mug that is vacuum sealed. Place both of these cups of water in the freezer overnight. Once frozen, you'll see that the simple plastic container produced ice that is quite opaque. Letting it melt, and here's what that looks like. However, the insulated mug produces ice that is almost perfectly clear, as you can see here. First, take an empty pillowcase and a dry chemical fire extinguisher. Place the pillowcase over the nozzle of the fire extinguisher and pull the trigger for a few seconds. As the high pressure chemicals are sprayed, the sudden drop in pressure decreases the temperature and causes chunks of dry ice to form. Placing these chunks in water, and you can see the dry ice sublimating, producing bubbles. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. If you thought all 3 of these videos were fake because today's April Fool's Day, nice job at trying, but only one of them was fake. It turns out you actually can scoop up dice quickly like this and bring them to rest while keeping them stacked on top of each other. The quick motion of the cup keeps the dice towards the bottom of the cup, and then rotating your wrists as you bring them to a stop gives you the best chance of them staying together. I'm not able to get it every single time, but with some practice, it's way too consistent to be considered random. And here's what it looks like using a clear cup and 4 dice. Freezing water in an insulated cup also does create clear ice. That's because the top layer freezes first, and then it slowly continues downward, which is called directional freezing. This pushes air bubbles and other impurities down, which otherwise would make it look cloudy. That means a dry chemical fire extinguisher like this does not produce dry ice when you place a pillowcase over it. You actually need to use a carbon dioxide fire extinguisher for this to work. Doing this does get you chunks of dry ice, but interestingly, these chunks are much less dense than the dry ice you can get at the store. As you can see here, they float in water compared to the store-bought dry ice, which sinks. If you ask me, this type of dry ice sorta looks like styrofoam. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 2. This plastic piece has 2 holes in the middle and is threaded on both sides, which allows you to connect 2 2-liter soda bottles to each other. These holes are sized so you can fit a straw in each hole like this, which will be important later. Next, fill up one of the bottles with water, and I'll dye it blue for better visibility. Next, screw on the connector with both straws attached. Now if I flip the bottle over, you can see that water travels up the straw periodically and produces a fountain-like effect. This is a bottle of pH indicator, which I'll add to a beaker of water. After mixing it up, I can now add a piece of dry ice to the container, and the dry ice will cause the liquid to change colors to yellow. If I take a partially inflated helium balloon and cut the string right where it's touching the ground, I can wrap the remaining string around the balloon, and I've created a balloon that has neutral buoyancy. That means I can bring my hands near the balloon and guide the balloon around without ever actually touching it. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Cutting the string of a helium balloon where it's touching the ground does allow you to produce a neutrally buoyant balloon that can be maneuvered without touching it due to static electricity, and it feels like you're using the force. Adding dry ice to a beaker of water with pH indicator in it does change the color to yellow. The carbon dioxide in the dry ice is reacting with the water to produce weak carbonic acid, which lowers the pH of the solution, causing it to be yellow. It turns out simply placing straws between 2 2-liter soda bottles does not produce this fountain. If it were just 2 normal straws in this device, the water would simply drain smoothly down one straw while air flows up the other. To make the fountain effect, you need to have several small holes at the base of each straw. These holes allow some water to get pulled into the straw as air is flowing upwards. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. This is a glass container with a hole on each end. If I place a balloon inside and use some compressed air to blow it up, it fills the container, but once I remove the compressed air, it immediately deflates. However, if I first cork the other end, now I can inflate the balloon, and the balloon will stay inflated inside the bottle even after the compressed air is removed. These are 2 big metal balls that can be used to show a conversion of kinetic energy to thermal energy just by swinging them together with a piece of paper between them. As you can see here, smashing the balls together burned a hole in the paper. If you drop a basketball on its own, it doesn't bounce very high, and neither does a tennis ball. However, if you drop the tennis ball and basketball together with the tennis ball on top, upon impact with the ground, the tennis ball will be launched really high and even hit the ceiling. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Dropping a tennis ball on top of a basketball does cause the tennis ball to go flying. Some of the energy from the much heavier basketball is transferred to the much lighter tennis ball. Smashing these 2 heavy balls together does produce enough heat to burn holes in paper. And here's what that looks like with a thermal camera. Corking the bottle does not allow the balloon to inflate and stay inflated. The cork actually prevents the balloon from inflating inside the container and just pushes the compressed air away once the pressure is high enough. I actually drilled a hole in the cork. That allows air to escape during the inflation of the balloon, and then I subtly plug that hole before removing the compressed air. Now that the cork is actually sealing it with the help of my finger, the balloon doesn't deflate because of the partial vacuum produced inside. Removing my finger and it will of course deflate. Before you head out, I wanted to let you know I'm releasing a multiplayer video game this summer called Stick Scholars, which is an online social deduction party game where players must parkour to school, answer trivia, and hunt down a hidden class clown who's sabotaging to try and make the entire group fail. You can watch the trailer for all the details, and if you're interested in playing, I'd love for you to wishlist the game on Steam. Thanks for watching to the end, and I'll see you next time.